We've got to move this industry forward. We have to break down the silos between developers and designers and contractors. Like, we're literally designing and building and shaping communities and the planet.
We're going to go through essentially setting up a problematic for you. Charles and Robert are subject matter experts, deeply knowledgeable in technologies that are changing how we build. A lot of what we're talking about today is parallel to what we've been talking about all day, whether it's Schneider Electric and how you make these things more efficient. We're going to talk about a basic concept, which is our metric for change in buildings is how do you either fundamentally rethink and eliminate or minimize the difference in trades, either before or on the job site or both. And then once it's there, what do you do with it? And so it's about productizing the built environment. And we're going to take it from two angles. One with Robert on timber, and what's that doing to change the built environment and how we're delivering buildings differently. He's also a subject matter expert on composite technologies, which again talks to a lot of different people in the room. And then with Charles, who is a manufacturer here in Asheville of a modular building technology that has been awarded as having the lowest carbon footprint in the country for this type of what has been around for a while, structurally insulated panels. I usually like to take a test. So how many people have heard the phrase embodied carbon? That is awesome. Usually it's one. So I will take that. So we're gonna talk about how we define product, how we think about it. We're setting up a polemic. So if you see holes in the argument, you've been very good at that today, sir. Please poke holes in it. That's the point of it. Why we're doing it, and then these two examples, and how we're actually doing this across the country and in Asheville particularly. So it's a really wonderful happenstance that we're here to talk about it.
Let's do introduction.
We're gonna, okay.
Right.
We'll do it. So what we want to talk about is setting this up. And our definition, as I just said, is product in the built environment delivered to a building job site. A lot of the technologies I see and deal with from my perspective in the built environment are things that speed it up, but not things that change it. So thinking about how you build a better horse is essentially 75% of what we see in prop tech when I talk to the prop tech community. I'm sure it is nobody in the room today in any way, but it is a reality. I'm sure you all see it too. So it's a parallel interest in how can we get beyond doing the same things. P. Jim talked earlier today about how the real estate market is just so flush with capital for 100 years, so it's really hesitant to change. So we're going to use stud frame construction as our whipping post of a technology in the building sector. Fundamentally unchanged, fundamentally weak, fundamentally susceptible to fire, wind, and damage, and largely dependent on skilled labor, however abundant or unabundant that is. So we have a technology problem. Now, Charles, could you tell everybody about your background? We'll start a conversation. Please join in. Coming from product to construction. And when we were setting up this talk, you talked to me about opportunities for error in the product world and how we don't even talk that way in the construction world.
So I come from the tech world originally. In the late 80s, I started working in the area of Research Triangle Park here in North Carolina. I was project manager for IBM's very first ThinkPad laptop computer through both prototype and product introduction. And wound up in Silicon Valley and was involved with running silicon wafer fabs in Japan, spent a lot of time in Japan over the years. And not many women in Silicon Valley. and came back to North Carolina, where I was born and raised, and settled down here in Asheville. And I recognized here in Asheville there were two things that were really big in the community. It was the green movement and real estate development. And they were trying to figure each other out. And the developer said, hey, you ought to look at, you're a tech guy, you ought to look at this new building technology, structural insulated panels. So I got into working with the building industry, 15 years in technology, 15 years now in the building industry. You know, when we were in the tech industry, following up on what Aaron had said, we were tracking wet silicon wafer defects in parts per million. Ask a builder about tracking opportunities for error in the manufacturing process. On your manufacturing site, which is a job site, and most builders, I don't even know if they get that it's a manufacturing site, they don't understand opportunities for error. Would you believe there are 5 opportunities for error associated with a single nail? That's another talk. But count how many nails are in a house. All these opportunities for error are actually making the insurance industry a whole lot of money. Builder callbacks are costing builders phenomenal amounts of money, all because we are still using building systems that are 200 years old. If Asheville is supposed to be some beacon of green, listen, people are still stud framing out the wazoo. Steel studs, wood studs, it's all stud framing. It's all the weakest and least energy efficient and most complicated way to build. And so we're trying to change that, that formula. And we're working with people like Dr. Robert Steffen to validate our products. We're coming at it from a new perspective that we'll get into. And we're working with, he's within the University of North Carolina system. We're working with the university systems because as a small company, it's less expensive to do so. They have the ability, they've got the skills to evaluate new products. And Robert's got a world of experience to do so.
I can't miss the chance to ask the question. Does anybody know what the weakest link is in a residential home for wind or seismic? What keeps your house up during a high wind event? Somebody said shear. Who said shear?
I know.
It's shear. It's the OSB on the outside of your house. And guess what controls the strength of the OSB on the outside of the house? The number of nails. So some contractors simply not putting in the number of nails could determine whether or not your house falls down in a high wind event or not. So that's where we are with construction. My background is I was a student at Georgia Tech for a long time, and then I went to teach civil engineering. Then I went to build sculptures made out of composites. Anybody seen the Denver, Colorado Center with the blue bear? I engineered the blue bear. And then I went on to do bridges, and then I went on to do General Dynamics work, and then I came to Asheville, same as Charles. When I came to Asheville, I had to start something from scratch because it's not New York City or Atlanta, so I got into a lot of residential home designs. And I teach at Western Carolina University, construction management. I do a lot of engineering for Charles's company, and we test for racking loads and things like that. So if I had to just mention the weakest link, that's one of the weakest links, but also it's high time to start using a hybrid of materials in places and buildings, not just OSB everywhere.
So there was a joke earlier about errors and omissions, and I think it was focused on architects, errors and omissions, which is great. I can tell you, I've never been asked to specify the number of nails in anything, in any drawing we've ever produced, nor would we? It's wonderful because Robert, you build at the scale of New York City buildings. Charles, you are looking at that scale, but currently you build at the scale of a single family residential house, but you've both identified overlapping problems.
Yeah.
Mm-hmm. So we have the technology problem. Then on top of that, we have the labor problem. So within that, there's the fact that the more we're working in the construction industry is not producing efficiency gains and hasn't in 100 years. We're able to do more because we have more capital and we had more people. But if there's a problem, Charles, counting the number of nails, how do you start to solve that from a labor perspective?
So what is striking about what you're looking at here is, so the chart before showed that there's basically been no efficiency, productivity improvement in the, at least the residential building sector in 60, 80 years. Crazy, right? And even recently it's gone negative. Why has it gone negative? It's gone negative. Who here, show of hands, who here knows what I'm talking about when I state the perfect wall? Ooh, got somebody back here. Okay, so a perfect wall is look, he's a brilliant guy, Joe Stiebrick, a building scientist with Building Science Corp, internationally recognized experts at construction. They are saying, hey, we've got these growing problems with, we want a home to be more energy tight. Well, a more energy tight home introduces more problems, potential problems with the building envelope. We've got stronger code requirements for insulation. For structure, let's take stud frame, a 200-year-old technology, and let's add layers of material, of more labor walking around this building envelope 3, 4, 5 times, and we're going to build a perfect wall. We kind of think that's crazy, but when you look at the negative productivity, and I confess I had never seen this chart before last 24 hours, we're seeing negative productivity where it had been relatively flat for 50 years because we are adding components to a dinosaur. Stud frame construction.
Building a faster horse instead of the Tesla or the Model T.
Yeah.
Mm-hmm. So there's a couple of ways we can unpack why we're doing that and what we're seeing in terms of change. Camillo, earlier today you said in one of the previous talks that you see 2 drivers for change in demand in your sector as a developer. One you said was regulation, and then the other said was, I think, a little less statistically minded, but gut, which is a generation coming up that's sensitive to climate impact and is just demanding change. They don't know what that looks like, but they're asking for it. Do I have that right? So one way to look at that is that within AEC, over the past 30 years in the United States, the majority of what we call innovation has been on building operations. It's what we would call solving half the equation, which is what you 2 gentlemen are doing, is trying to solve the structural side, the other half of the equation. So there's 2 problems with solving for building operations as your sustainability factor. One, sustainability, green, whatever you want to call it, it's all measured how much carbon we put into the air over a 30-year period. That's been shrinking, but that's where we started with Paris. It's changing with Copenhagen. So if you're talking about impact over a 30-year spectrum, and you're saying we are within 5 to 10 years of being too far gone with 1.5 degree change, then building operations aren't going to do it for you. There's no sustainability in building operations. It's important, but it's just slowing down the car. What we have to figure out how to do is actually run the car in reverse at this point with the time allowed. The majority of the carbon footprint in our built environment over that period, actually stretching up to a 50-year period, is immeasurable within the period of construction, from sourcing and delivery to the act of building on site and how we do it. So materials like Charles is developing will show you, like Robert engineers, they're looking at how you change the way we build to think about the carbon footprint in that time frame. Because by all intents and purposes, the terms we've agreed on how to mitigate climate change, we're not addressing in the AEC world largely. We're doing the right things. Everybody is well-intended and effective in what they're doing, but it's only solving for half the equation. So to Camilo's point earlier, what's going to get us there? What's driving people to adopt Robert's timber buildings or Charles's prefabricated wall assemblies, and we'll dive into those. Well, from the top side, we have 4 examples for you at the federal level, and then let's take 2 of our biggest economic sectors, New York and California. They're coming for you. New York City, where we're based, I can tell you we have this argument with landlords and developers all the time because, admittedly, it's really hard to think in a 30, 40-year cycle about your building costs. But by 2030 to 2050, New York City landlords are risking current operational fines of $10 billion or higher on an annual basis on buildings they already own in the city. So that's an analysis. If we're just running operational efficiency on the built environment as it exists today, with moderate gains year over year, $10 billion in negative activity in the economic market in New York. California, always doing its own thing. They're requiring builders and developers to start paying for solar and panels and batteries now. So they're already increasing the costs in our 2 biggest markets to build. But if you look at it over a 50-year or 30-year cycle, what you're saving over time starts to come into the conversation more, which is, I think, how we 3 think about it. Then, to wrap it off and jump back into your technology, Charles, what's the federal level? We just had GSA here. We work with GSA frequently. Right now, they have an optional procurement policy on buying sort of green products. This is where the word embodied carbon comes in. Embodied carbon is the next level of building technology and sort of green status in the United States. So right now, your building can run operationally relatively clean. That's great. You can get a credit for that. But what is going to actually change the construction industry, and New York is talking about adopting this currently, is what are the materials you're building with, and what's the carbon footprint of the materials you're building with? That's why low carbon footprint materials, like the ones we're discussing today, are critical to use and adopt now and learn how to build with now, because they're going to save you money over the next 40 years. So it sort of fundamentally flips the way we think, I think the 3 of us think about the supply chain, which is instead of responding as an architect, I want the building to look like this. I want the building to function like you need it to function, or you tell me it has to function. And then I'm going to source the building, and that's going to determine how the thing actually looks.
That's not a simple thing either. California, for example, they recently passed the new laws that require all new buildings to be net zero. Great. How do you get there? Let's put 30 solar panels on every roof. I've got a buddy from the company that we sold when I was out there, lives in a 10,000 square foot home on the top of a hill overlooking the valley, and he claims full sustainability because he's got 100 solar panels keeping him basically powered for his 10,000 square foot home. Wow, that's crazy. If that's the way we get there, you know, wouldn't you like to be in the solar panel industry, except it's a commodity. That's a tough way to go. How about for those same 30 solar panels, you build a super energy efficient home that you could have, you know, 3 or 4 homes operating off those same 30 panels. And that's where we are trying to point people. Now, listen, all the crazy incentives go towards solar. They started early. They got real good lobbyists out there. And there are a whole lot of incentives to go, to put solar panels everywhere. There's actually very little federal incentive to build a more energy efficient structure in the first place.
But that's what's changing, and that's what we're looking at coming, and that's what the critical developed states are going to lead with in the next decade. New York City is going to require in the next year that every single city built, sponsored, or subsidized product has to have a carbon footprint analysis that goes down to the material selection of the building. That will start to drive an ecosystem around it, because if you want to provide the largest landlord in the city with anything that gets to his building, whether it's low carbon footprint concrete or glass for the facade, you're going to have to partner with a carbon analytics company, and you're going to have to understand where it's coming from, how it's being made, what's in it, and show them that before they'll approve it in their procurement cycle. So the two examples that our gentlemen are bringing to the table today are structurally insulated panels and mass timber. They share a lot of things. Timber is here because it's the large scale side, which probably is much more relevant to most people in this room, but 92.5% of our buildings in the United States are 4 stories or less. And so the structurally insulated panels technology is really relevant to anybody in the built environment. So we're going to start with that one. So Charles, do you want to talk about how this kind of thinking about framing and insulation and performance affects the labor requirements of a site, which is a level of change we defined early?
Sure. So if you look at the images, we're looking at the panels are basically modules that are brought onto the job site in a kit. And the panels, you can have a window panel, a door panel, a corner panel, which is unique to our company for the continuously insulated building envelope. They can be made out of different siding materials, but the idea being these are not just structural, they are pre-insulated. And there are different types of foam. We use a closed cell urethane foam. Fewer than 5% of the players in the market, like a Yeti or an Igloo cooler, use a closed cell urethane foam. Your house could be like that. Heat it with the matchstick, cool it with an ice cube is the mantra. But when you have a product that can be built in a factory, brought to the job site, and erected by high school students to build the strongest and most energy efficient home in the community, in the state maybe, and we've done it. That's crazy. If you think there's a labor problem, and there is, skilled labor in the construction industry, if you supply a product that could be put together by the homeowner, you now don't have 500 different builders in the country. You've got 5 million.
So that's the scale, let's say, from 3 feet upwards. Can you talk about the epic block approach? Because this to me starts to get more to that structural issue, buildings like what we're sitting in here. And what you told me about not needing a mason was really interesting.
I'm a fan of California, Northern California. I used to live there. I'd love to get back there someday. I wanted to, so 2017, 2018 saw, this massive wave of fires in California. How can we help these people? If we took a wood-sided panel to Paradise, California, I don't think we're going to get a lot of respect, even though our foam never melts and it's fire retardant. If it's got a wooden skin, it's going to have a negative connotation. So I said, how can we create a product that anybody, if you If you level the slab, their house just burnt down, but they're a property owner. That's their land. That may be the single greatest asset they own. That slab has stub outs for plumbing, water, sewer. They're not going to take a wooden skin panel, but you know what? And after a disaster, you will never find enough builders. You will never find enough building supplies because everybody's looking for the same stuff. Everybody's looking for that skilled labor. If you gave people 1 million blocks and said, you know what, rebuild the home as you wanted it to be. Now it's fire retardant. These blocks, I'm proud to say they were the most awarded building product on the planet in 2021. They can be bonded with construction adhesive. And there are various different varieties of doing that. And all thread rod is holding the block in a compression fit. So you don't need rebar. You don't need a cement truck coming to your job site. You don't need a skilled mason. Listen, there are fewer and fewer skilled masons in this world. The government's one of the largest property owners in the country, or they're the largest property manager in the country. What are all the buildings made from? Concrete block, just like this wall here, which is just about the least energy efficient way to build a building. Half the schools in America are built with this block, or more than half. Least energy efficient, we do it for safety. We sure as hell weren't concerned about energy efficiency. That's an R40, was an R40 block. R40, that's passive level of insulation in all 50 states.
So I think what's critical about the two things that you're showing here is that there's a wide gamut, that they deal with a lot of different problems. They're all trying to solve for one thing, a better performing building during the act of construction, not after we're running it. The difference between the wood and the concrete version being, okay, now we're talking a total structural package. What can that look like? The project that Charles and I are involved in together here in Asheville is a luxury development. 21 houses on the mountain overlooking downtown Asheville. They're made from a combination of these products. There are 5 of them starting construction between now and the beginning of January, and they all look different. So every single person moving in gets a unique home that's classified to them, that can be tweaked, that can be added on, that feels extremely personal and looks like a luxury home. But one builder is going to be moving between 5 sites with an anonymous product. What's an anonymous product? It's a block and it's a wall sample, and they're going to be able to put them up. Where we have some difference, windows and things like that, they'll be tagged, they'll be scanned with a phone, they'll get to the job site, and there'll be an instruction kit. So across 5 homes, we can actually start to beat the price of local builders using local construction technologies that have been around for 200 years and get high performance building envelopes. These, Imbue is a really interesting company. We were hearing from them earlier, and I think tomorrow, they're the guys who put these sensors all over multifamily buildings to make them super efficient, right? It's great, it's necessary, but if your building is already super efficient and running half of the energy and air and heat and cooling loads of the buildings that Imbue is required for, you're getting there already. So again, it's a way you get more value for your dollar long term out of rethinking construction before you even get to the operational issue.
Now, one thing, you mentioned sensors, and I was very attentive to the previous discussion of sensors. Again, my background applied physics, I come from the tech industry, and I'm all about sensors. When you talk about delivering value to the client, we can embed technologies in our panels, so in our blocks. This block wall could be a sentient wall. This block wall could know if it's leaning. This block wall would know its relationship one block to another. This block wall would know the interior temperature, the exterior temperature. You know what one of the single greatest banes of our society and energy consumption is the thermostat, including the Nest. Where's that thermostat located in your home? Probably a hallway.
In front of a window.
It's not in front of a window. It's in a hallway.
Where you're not sleeping.
Nobody here
Yeah.
lives in their hallway.
Yeah.
But you don't want to see it.
You don't have to see it if it's in the wall.
Exactly. So that's the residential scale, and we want to take questions. I want to get Robert, I really want to get you involved, so I want to go to everybody who's working at the urban scale. This is where mass timber comes in. So just for reference point, I want to kick it to you, but right now this technology is building the HQ2s and one HQ1 for Microsoft, Google, the Walton family is doing an entire campus of this in Bentonville, and the tallest wood timber building in the United States just reached 25 stories. So it's the beginning of a real revolutionary change. We're later than Europe, not much of a surprise there. But can you tell us, define it what it is for people? I think we have a really
Sure.
educated audience, but always
Sorry,
helps.
I'm not staring at you. I'm looking
Yeah,
at the monitor.
no.
Could you click to the next one in?
Yeah, of course.
Maybe the next one.
So
the next-
Robert was a structural engineer of one of the very first mass timber buildings in New York City.
The next one, if you don't mind. Next one. Next one. There we go. Okay. So here's the benefit of mass timber in a nutshell, okay? Aesthetics, fast installation, okay? Structural. In the past, we thought wood was terrible with fire. Turns out mass timber chars like a blackened steak and then protects the inside, and it's actually better performance than most of this steel you see up here that gets sprayed with a spray that's not always put on exactly as it should, right? So, yeah, general rule of thumb, 1.8 inches gets you 1 hour of fire rating. So if I need to design this beam right here out of wood, and it needs to be 12 inches structurally, we'll just make it 13.8 for a 1 hour rating, and then it's going to be a little wider. But this is a 670 Union Street in New York. We just wrapped this up. Structurally, if you go to the next slide, the beams and the columns went in 1 day per floor. 1 day. So the truck came from Washington State, drove across the country. Soon that won't be the case. There'll be more people on the East Coast. Came from Washington State, stayed at a New Jersey truck stop Sunday night till about 5 a.m. on Monday morning. Then it drove across, it is at the Verrazzano's Bridge?
Yeah.
Verrazzano's Bridge into Brooklyn, and in about 4 hours put in the beams and columns. I have them in my car. I was going to bring you a sample, but the connectors hold about 17,000 pounds that you see on a beam here, and they're pre-attached to the column. So when it's delivered from the manufacturer, it has the column attachment on it. It gets put in, the beam comes down and slides on top, and you put the 4 dowels in about 5 minutes. So extremely fast installation, number one. Number two, you get the aesthetics of the system. And number three, the masons that did the work on the job, the next slide here, if you don't mind. The masons here took about 2 weeks per floor. And so while they're putting the masonry block on the project, the water's running down, it's interfering with the beautiful wood, you're trying to protect it, and we're waiting, and we're waiting, and we're waiting. So on Monday and Tuesday, the beams and columns went in. On Monday, the beams and columns went in. On Tuesday, the floor planks went in. And the floor planks are the exposed wood that you see in the previous slide. So the value add is extremely fast installation, no scrap, zero scrap on the job. The truck, when it left, it was gone. And this was in an urban street, Union Street in Brooklyn. The neighbors loved it. The contractors told us that they had an identical job about 5 blocks away out of reinforced concrete, and it was a totally different scene. The trucks are lining up in the morning. The drums are running, and the clock is ticking. So we're doing this for multi-residential also. We're doing this obviously for commercial, but we're having a showcase project in Washington State also that's a residential to prove that we can do it very fast and cost effective for just single family also.
So one of the things to point out, and if anybody wants to target specific markets, Robert's a great person for that. The only reason that masonry is there at all is because of code requirements. that are getting reviewed. So depending on where you are in the country, you can put this thing up almost entirely in timber, and you don't have to think about cure times on a concrete floor and waiting for your electrician, because you can run all your conduit paths through all of this material, either Charles or Robert's, before it ever arrives to site. So they're just pulling it once they get there. So there's a lot of efficiencies to that. Same with acoustics, it all comes built in. So the Ascent project, this is the tallest one that just started leasing in the country. It's 5 stories concrete, because it's how you got to the height that made the model work, and then everything else you see in there is 100% timber going up. That's the built environment below. Between this project and the projects that exist in London, of which there's like 13 or 14, the lease rate is 75% faster over a 12-month time span than competing inventory and traditional materials. So people like it more. That's another way to start to expand the analysis of how do you make the model work. If my construction cost is X for timber, but I can deliver it 3 to 5 months faster to market, and I'm going to lease it up 30 to 70% faster, well, maybe all of a sudden my model says my carrying costs are cut in half, so I can actually spend that extra money up front. So that's what they've been modeling across the country. And Robert, you can talk about this, but one of the advantages, right, is the difference in weight that we can add to our infrastructure.
Exactly. So a small example, San Francisco Museum of Modern Art, that was, if you ever see it, it's a beautiful facade that has doubly curved composite material panels. The engineers were brought on later. The composite material was put on later. Turns out that if the structural engineers of record would have known that we were going to use these lightweight panels from the get-go, we could have saved dozens and tens of thousands of dollars in the foundation. You know, it was lighter material. Also fast. Mass timber, same way. It's lighter. It actually performs extremely well in seismic events because it has some what we call redundancy and ability to, if you engineer it right, some ductility. And it's lightweight. Buildings are like lollipops on top of each other. And when the earthquake shakes, the lollipop, the bigger the lollipop, the more the column moves. So what's
this? I think there's 2 points to tie this back to Sam, the keynote speaker who was just here. One thing he had that I thought was really interesting in his deck, if you noticed it, there was a whole sector that was above that. There were 3 sectors above the S&P 500, 2 of which, including industrial, you'd expect to be there. The third one was timber. And I don't think it's an outlier that timber's there, and the fact that it stayed up through the pandemic, even though our material prices are dropping, is a really interesting factor. So Robert, we had a slide earlier, we don't have to skip back to it, but this building is about densifying our built environment. So adaptive reuse, everybody knows that phrase. Another way to think about it, and how Sam was talking about it, I would pick a little bone with him when he said, you know, all of these old office buildings in places like New York City, a lot of them can be repurposed for residential because that's where our coming needs are. There was so much change for about 80% of that stock would be required to make those work in ways we're not able to do, like just basic access to light and air and egress. There's other ones that can work, but about 80% of that stock can't. What you could think about is literally a stacked economic model. How could I add residential on top of existing commercial? Yeah. That's because timber's so much lighter.
Yep, there's a developer here in Asheville that's looking at commercial buildings that are cement block right here. Yeah. You take the roof off, and we have another person that Charles and I are collaborating with that can produce roof material that's a 1/4 pound per square foot. This is about 30. So lightweight, very fast. If you can take off what you've got up here and put something lighter, you can go 2-3 stories on an existing 1-story coffee shop.
We're essentially out of time, so I'll show this last slide, which is Hines is a developer, international, everybody's heard of them. They've conceptualized, they bought an architecture firm and conceptualized timber as a product. So they have a relatively constrained set of drawings. They call their product T3. They find a transit hub like a metro line. They find a need outside Austin, outside Minneapolis, they put a WeWork in there or they put residential in there, and they stamp out a slightly different looking version of a timber building, whatever height will allow them to do it. So they're thinking of a productized asset that can go commercial for office or flip to residential, because these are all really light point-loaded frames. You take a floor plate out, all of a sudden you have a light shaft down the middle. You don't have to cut through concrete or anything because it's just wood. You need a saw. So it's a product that can go either way and retains flexibility. So that's what we would sort of, there's a lot of different ways to define product in the built environment. This was two of them. I think the point we really wanted to talk about with everybody, we're out of time today, is that you got to solve for the other half of the equation, which is changes in construction, not just changes in operations, if you want to have an impact and meet the coming demand for truly green infrastructure. Thank you.
Any questions?
Do we have time for questions? We have a minute or two for any questions on this subject, or of our, what they're.
Who's doing the asphalt product? You're the developer, builder?
Our developer is sitting right here, David, with us. He came to us and asked us to conceptualize what a truly energy efficient, modular built development could look like down here. We were very fortunate in that partnership and envisioning process to find that technology already here.
Who's the target market for the home?
Target market for the home is you. No. It's a broad sector. I mean, going back to what Sam was saying, it's a really good topic because it's a luxury housing. It's ex-regional, right? There's some regional, but it's people moving out of those in part. You know, the majority of the workforce can't relocate, but a good deal can. Really good school systems, a lot of the other advantages. Asheville's a place on the rise with a growing economy beyond tourism on its own. I don't know if you saw...
A lot of tourists here.
A lot of tourists here, but they're, you know, it's that sort of core sweet spot. It's climate retreat from Florida. It's second primary homeowners. I don't know, the Wall Street Journal did a huge article on this, probably 2021, middle of the year, in which, sorry, we're so close, in which they were listing out a trend around the country, slowed only by those with kids, because for a large demographic of wealth in the country, there's only one inflexible object left for that demographic to move around wherever they wish, and that's schooling. But outside of that, and even in light of that, places with really good school districts do better than everywhere else in the country on attracting residents away from other centers. And then two, people who have two first homes. They're in one for 6 months, they're in the other for 7 months. I mean, KP seems like an example of that.
Is KP buying more of these?
Not to my knowledge, but he's welcome to.
What's your ratio between land cost to total cost?
You want me to battle it? Well,
right now, it's probably about 2/3 to 1/3, approximately. 1/3 land cost.
Is that typical in this market for a third being land?
That's a little, it depends. It depends on where you are. Now, I live here, and Charles, we could answer it. Maybe David lives here. I would say less than a third?
25, 75.
Okay.
Again, somewhere in that range.
The last couple of years with COVID have dramatically changed property values in this community.
Yeah.
It's not what it used to be.
That's why that had to be a pricey piece of dirt.
I know a lot of people from San Francisco and New York City that moved here in COVID, and they're still here. And they're still working for their companies in New York City and San Francisco.
So the Explore Asheville folks, are you a tennis fan? Did you watch Serena's last matches? Okay, everywhere behind Serena's head said the word Asheville, because the same people who were sponsoring this event, really savvy marketers, they were sponsoring all over the US Open. It was like, oh, it was great. So we were very excited about that, as you can assume. We sat with them. They have demographic trends. They've already eclipsed, in terms of drivers to the market and flights to the market, their 2019 totals. So they wherever they dropped in flights, They made up for in this region with long-term stays, people renting houses, totally comfortable, hotels drop, and drivers. And they track every cell phone, including ours. This one actually seems beneficial. Coming into the market, how long you stay, how long you exit. So we sat with those folks and said, where are they coming from? Where do you think they're going to be coming from? And that continues to go like this. And so it's a relatively seemingly under the radar area for this, but the land's here, the construction's here, and the demand is here. I guess our hope and our thesis is that this is a really good place to do it, but the fundamental thesis of selling someone a home that's essentially a carbon credit to them is a really good feeling and will eventually be something that they can trade cash in on.
Asheville had the first hemp-based home in America. Hemp construction is a growing thing, and we were actually part of that. We provided the roof for the hemp block walls. But it's a good environment for innovation.
So thank you for your time. We're out of it.